Hello all. In this video we will see recursion and stack unwinding. So consider this example. You can see here we have defined a function called as f, which takes an argument n, which is of type integer. When the function executes, it prints the value of n. Then it checks if value of n is less than 10, then it makes a recursive call to the same function with argument as 3 into n minus 1. Okay, and the last statement of this function is again printing value of n. Now here we have main gives call to this function f, and the argument passed to it is 1. Okay, now let's see how this code executes and how recursion and stack are used. Okay, so imagine if we have a runtime stack, right? So we have a runtime stack. You know, stack is a last in first out structure. The very first function which we have called is main, right? Then main gives call to this function f. So function f is called for the first time. What we have passed is 1 as an argument to it, right? So that will be copied into n, and n will be part of that stack frame for function f, right? So n is 1. Now what we are doing, we are printing the value of n, right? So if I write an output over here, then the first output will be 1. The first output will be 1 because I'm printing value of n as 1. Then I check this condition. If 1 is less than 10, 1 is indeed less than 10. So we make another recursive call to the same function. So the same function is called again, and for a different call to the same function, a different stack frame is pushed onto the stack, and that stack frame will have a different copy of n. Now this copy of n will have a value as 3 into n minus 1. The existing value of n is 1, so 3 into 1 is 3, 3 minus 1 is 2, so n is 2. Okay, so now the same function is called again with n as 2. Again we print the value of n by 1, which is 2. Now we check this condition again, that 2 is less than 10, which is also true. So again we call the same function again, right? F into 3, f of 3 into n minus 1. Now what is n? N is 2. So 3 into 2, 6, 6 minus 1 is 5. So third call to the same function f with value of n as 3. Oh, not 3. I made a mistake. What is it? 3 into 2, 6, 6 minus 1 is 5. Okay, so n is 5. Third call to the same function, n is 5, you print the value of n. So that is 5. You again check the condition, if 5 is less than 10, 5 is indeed less than 10. So 3 into 5, 15, 15 minus 1 is 14. So fourth call to the same function is made, right? With n as 14. Okay. Now n is 14. 14, you print the value of n as 14. You check this condition, 14 less than 10 is false. So now you will not make this recursive call. So you will directly come to this printf statement, which prints the value of n. What is that? 14. So you print 14 again. First 14 was printed due to this printf. Next 14 is printed due to this printf, right? So twice 14 would be printed, and then we exit from the function. So when we exit from the function, this is popped out. We go to the previous call. Now in each of these previous calls, This statement is yet to be executed, right? This statement was a leftover, right? That was a statement after the recursive call, which is yet to be executed. So that was a backlog actually. So for every such call, this printf will be executed. So for in the third call, value of n is 5, so printf will print it as 5, right? Then we pop out that, we go to the next call, the previous call, that is n is 2, so we print 2, right? That's also popped out. You go to the first call, n is 1, you print that value 1, and that is also popped out, right? So that is how the stack unwinding happens. Okay, so when you look at the output happens to be 1 2 5 14 14 5 2 1. Okay, I hope you have understood this. Thank you.